Yeah, so one of the things we've recognized is that users of Styra DAS often want to apply infrastructure as code or everything as code principles to Styra DAS itself. And so earlier this year, we launched support for a VS Code plugin and a CLI that allow you to manage and control your Styra DAS systems and stacks and libraries through CLI or through Git, basically. So what it means is that it's much easier to sort of automate the deployment of new systems through Styra, as well as to manage the configuration of those systems in your native IDE, right? So rather than having to go into a GUI and click around and do things, you can now just do that natively from inside your IDE, or you can also automate it more easily from inside of like a CI/CD pipeline, where you might be storing the source of truth for your DAS systems and stacks. So Styra Load helps with data-heavy authorization use cases in a couple different ways. The most fundamental way is that it delivers a new in-memory representation for data and policy that is much more efficient than what is supported by upstream OPA. So from our testing and our initial customer trials, we found that it speeds up policy evaluation by 40% and reduces memory usage by almost 10x. So what that means is that it unlocks sort of use cases that OPA could not previously really be applied to, right? Because if your policies and your data are going to consume gigabytes of memory, it just wasn't feasible to deploy it for that use case. But now with Styra Load, our enterprise-grade OPA distribution, that's not the case. It takes much less memory, and therefore you can apply OPA to much larger data sets. The other way it helps with data-heavy authorization use cases is through the data fabric functionality inside of Styra Load. And what that is basically built-in connections to popular data sources like Apache Kafka, for example, where you can very easily hook up OPA to Kafka in order to get important contextual information or data that's required in order to make policy decisions. So if you for example, wanted to have policy decisions made based on product inventory that was contained inside of a Kafka topic, you can very easily load that data up from Kafka and then use it to make decisions. Maybe you want to say that this product cannot be sold to certain geographies or something like that, right? And so it enables very fine-grained attribute-based access control use cases that weren't previously possible or required a lot of sort of do-it-yourself development effort on behalf of OPA users. Yeah, so I'm at KubeCon this year. Styra is very excited to announce our new product called Styra Load, which is an enterprise-grade OPA distribution. It's a drop-in replacement for Open Policy Agent that improves performance, reduces memory usage, and helps teams that are deploying OPA get to production quicker. Yeah, so in terms of roadmap for OPA, the project itself is fairly mature. It's been around since 2016. It's adopted by a large number of organizations. It's running at scale. And so we put a lot of emphasis into making sure that anything we ship is performant and reliable and going to last into the future. One of the areas that we've been focusing on recently have been some language improvements to the policy language to make it easier for people to read and write policies. And so we're gradually rolling those out, and we're hoping that by later this year we'll have a 1.0 release of the project that'll make those language improvements on by default without breaking any existing policies. So we're putting a lot of work into making sure that upgrade path is very smooth for users, and that's what we're focusing on in sort of the core of the project. But of course, the project is more than just that engine. It's also integrations with popular technologies like Kubernetes, Envoy, and so on. And so we're always looking for new integration spots where you can take OPA and apply it to new use cases. There's all kinds of vendors here at KubeCon that are demonstrating their Open Policy Agent support, whether it's a Kubernetes management platform or a CI/CD system or an API gateway. We're always looking for ways that we can extend the set of software that OPA can be applied to. So Open Policy Agent is a general purpose policy engine. The thing that sort of separates Open Policy Agent from any other project or product in that category is that it's not really tied to any particular domain or technology or language or protocol. So it really allows you to take policies and enforce them at any layer of the stack, at the API level, at the application level, at the database level, or inside of your infrastructure with Kubernetes, Terraform, public cloud, service mesh, and so on. And so, what OPA really gives you is that language that you need in order to enforce policies across all these different domains or use cases, and then a set of APIs that allow you to manage that engine. So there's APIs that allow you to control policy distribution, understand the state of the engine as it's running, as well as collect what we call decision logs, which are basically like an audit log of all the policy decisions that the engine is making when it's asked for those by applications or services or infrastructure. So OPA really, the way to think about it is that it's a building block that enables unified policy and authorization across the stack. Yeah, so I mean, access control is becoming a really difficult problem for organizations to solve, especially as they move to microservice architectures, because like what I said earlier, they have all these different programming languages and frameworks and protocols and formats and databases that policy and access control have to be applied to. And so, going forward, organizations really need to think very carefully about how they solve access control, and critically, they need to think about decoupling authorization or access control from the rest of the application, from the rest of the APIs. If they don't do that, what it means is that they're going to have authorization and access control policy littered throughout their application stack, which means that they just can't they won't be able to understand the sort of security posture, the access control posture that's in place in the organization. So they have no visibility, and then because there's no visibility, they can't possibly have any control. So security teams that want to roll out some new access control policy around devices that people are logging in on, or parts of the world where they might be logging in from, it becomes very, very difficult, if not impossible, to enforce those kinds of changes. So it's absolutely critical that organizations think about or understand the need to decouple policy and authorization from the business logic, from the rest of the application. Yeah, so Styra gives organizations sort of the best of both worlds. It allows security teams to ensure that important rules are being enforced and put in place without slowing down development teams, right? What organizations want right now is the ability to get their products and services to market as quickly as possible, but at the same time, all of the old rules that have to be applied from a security perspective, from a compliance perspective, don't go away. And so the question is, how do you give developers something that doesn't get in their way, but also gives the security teams what they need in terms of control over APIs, over the infrastructure, over the data, and so on. And so that's what at Styra we're focused on, is basically providing developer-first security that appeals to all camps, basically, and that also critically can be applied across the stack, because security isn't just inside of Kubernetes or inside of the API, it's really truly a full stack. It's something that affects every part of your system, and so you need technology that is flexible enough to be integrated at all these different points and expressive enough to deal with the different use cases that pop up necessarily with those different technologies. So the move to microservices is great because it's allowing development teams to get to market quicker, it's allowing them to ship features faster, but at the same time, every organization that's going through the transition from monoliths to microservices have to deal with this challenge of authorization. In the old world, it was a lot easier to solve authorization inside the monolith because it was just a library that you would link in and you'd add it in the right spots in the code base and you'd basically be done. But now with microservices, you've got potentially applications that are being decomposed into hundreds or thousands of smaller services that are owned by different teams, that are being written in different languages, that are using different databases, that are being exposed on the internet using different technologies. And so what you absolutely cannot afford to do is have a different solution to authorization in each one of those services. And so with policy as code, with Styra, with Open Policy Agent, what you can do is decouple authorization from the microservice and offload it to a dedicated engine that gives you everything you need to express important access control rules, but still enables centralized governance and centralized control over those APIs. Yeah, so policy as code is critical for organizations as they move to cloud, as they move to modern architectures. What we see is that modern cloud-native architectures are characterized by very diverse or heterogeneous kind of deployment environments where you've got one of every programming language, one of every database, one of every platform basically to run your application on. And at the same time, those environments are incredibly dynamic and ephemeral. So, developers are pushing changes every hour, right, to the application. And so the only way that you can keep up with that from a security, a governance, a compliance perspective is by taking policies that traditionally would have been written down on a wiki or stored in a PDF and codifying them as code and then getting them enforced automatically throughout your application, throughout your infrastructure. All right, so yeah, everything as code is about taking standard software development best practices and applying them to things outside of what we traditionally think of as software. So, for example, infrastructure as code is about taking those best practices and applying them to infrastructure configuration, cloud configuration, Kubernetes, containers, and so on. Policy as code is about taking those same best practices from software engineering, like code review and testing and ability to do rollback and audit, and applying them to policies and authorization rules that govern security within the organization.